All right, lesson 18 is a continuation of yesterday. Remember, we started talking about asymptotes yesterday, straight lines that get infinitely close to a function's graph, but never actually meets or crosses the graph. Yesterday, we talked about vertical asymptotes, or lines that are up and down. Today, we are talking about horizontal asymptotes and how to find those. So let's take a look at the examples here. All right, so if I take a look at number 3 here, I'm calling it number 3 because, like I said, this is a straight up continuation of yesterday's lesson. So to find the horizontal asymptotes, we're first going to separate out the fractions and simplify. So what do I mean by that? My function for number 3 is 120 minus 4x divided by x. What I mean by separate out the fractions is I'm literally going to divide out both terms in the numerator by x. And that's going to look something like this. So I'm going to do 120 divided by x minus 4x divided by x. I literally just separated out the fractions. Both parts of the numerator I divided by the denominator. Notice I put a minus in between because of the minus up here. Okay, so I separated out the fraction. Now I'm going to simplify. Now, if I look at the first term, 120 over x, there's really no simplification I can do. But the second term I can, because I have an x in the numerator and an x in the denominator. By rule, if I have the same thing in the numerator and denominator, I can cancel those out. So I can cancel out those x's there and make it minus 4. Okay. And if I go back to the lesson notes, the constant term, or the constant, tells you where the horizontal asymptote is. So the horizontal asymptote is going to be at y equals -4. Okay. Now, why equals -4? Because horizontal lines. Horizontal lines start with y equals. Vertical lines, like the ones we saw yesterday, start at x equals. Okay, so to give you an idea of how that looks, if I look at the Desmos graph, okay, there is my graph of number 3 here, and you can see it's got the same general shape as yesterday. And if I were to graph that vertical line at y equals -4, having some technical difficulties here. Okay, again, I get a horizontal line, blue line there at -4, and you can see if I were to zoom out, okay, with zooming out, see that blue horizontal line gets infinitely close to it. It almost looks like it merges with it, but it doesn't actually do that. It gets infinitely close, but never crosses the red graph. And that is the definition of an asymptote. Okay, so number 4, we're going to do the same thing. So 500 minus 8x over 4x. And I'm going to do the same thing I did before. So I'm going to separate out the fractions. So 500 over 4x minus 8x over 4x. And I'm going to simplify. So in the first term, 500 over 4x, I can't get rid of the x, but I can simplify 500 over 4. 500 over 4 simplifies to 125. So this becomes 125 over x. Again, how did I get that? I just divided 500 by 4. On the left hand, on the right term, the second term, I can do 8 divided by 4, which I know is 2. And then just like I did before, I can cancel out this x with this x. So the two x's will cancel each other out. And then 8 divided by 4 is 2. And then just like we said, the constant term, so in this case, the constant term of -2 tells you where the horizontal asymptote is. In this case, it'll be y equals -2. And again, just to give you an idea of what the graph looks like, here is the graph of number 2. Same general shape. Let's graph the asymptote of y equals -2. Okay. And again, we have the same thing. That horizontal blue line gets infinitely close to it, but never actually crosses it. Okay, so that yesterday, again, we talked about vertical asymptotes. Now we talked about horizontal asymptotes.